Welcome to a new module focused on the second pillar of object-oriented programming, inheritance. Inheritance is a powerful concept that allows us to define a new class based on an existing class, reusing its properties and behaviors. This is a crucial tool for achieving code reusability and establishing natural relationships between classes. 1. What is inheritance? Inheritance is a relationship. For example, a dog is an animal, and a savings account is a bank account. When a new class called the child class or subclass inherits from an existing class called the parent class or superclass, the child automatically gains all the attributes and methods of the parent. 2. Benefits of inheritance. The main benefit is code reusability. Instead of copying the common attributes and methods, like a deposit function in every type of bank account, we define them once in the general bank account parent class, and all specialized account types inherit them. This reduces redundancy and makes maintenance much easier. 3. Basic inheritance syntax in Python. The syntax is very simple. To make the dog class inherit from animal, you place the parent class name, animal, inside the parentheses after the child class name, class dog parentheses animal. By doing this, the dog class instantly inherits the eat method from animal, even though we only define the specialized bark method in dog. To summarize, inheritance is foundational to OP design. Our next lecture 18.02, Inheritance in Action. See you there.
Welcome back. In the last section, we learned the basic syntax for inheritance. Now, let's see this powerful principle in action. We will use the animal and dog example to demonstrate that a child class object can execute methods defined in both the parent class and itself. 1. Reviewing the parent and child classes. Let's use a common example, vehicle and car. The vehicle class, our parent, defines the common behavior start_engine. The car class, our child, inherits from vehicle and adds its specialized behavior, drive. Note that the car class definition is very clean because it doesn't need to redefine start_engine. 2. Creating the child object. When we instantiate a car object, my_car, it contains all the attributes and methods of car plus all the attributes and methods of vehicle. We can easily call the child's own specialized method, my_car.drive. 3. Accessing inherited functionality. Now for the core of inheritance. We can call the parent's method, start_engine, directly on the my_car object, even though that method is not physically written in the car class. Python knows to look up the hierarchy to the vehicle class, find the method there, and execute it. This is the essence of code reuse. To summarize, inheritance ensures that common functionalities are defined once and automatically available to all subclasses. Our next lecture 18.03, Inheriting Functionality. See you there. Welcome back. So far, we've focused on inheriting methods. However, inheritance also extends to data. A child class inherits both instance variables and static fields from its parent class, allowing objects to share and reuse data definitions. 1. Inheriting static fields. Our parent class, vehicle, defines a static field, will_count equals 4. Since static fields belong to the class definition itself, any subclass, like truck, automatically inherits them. The truck class does not need to redefine this shared data. 2. Accessing inherited static fields. When we create a truck object, we can access the wheel_count directly from the object or the truck class name. Python traverses the hierarchy, finds the field in vehicle, and returns the value. 3. Inheriting instance variables. Instance variables like name in the animal parent class are initialized inside the parent's constructor. When a child class, like cat, defines its own constructor, it overrides the parent's constructor. This means the parent's constructor is no longer called automatically, and the instance variable name is never initialized. We will fix this initialization issue in the next section using the super keyword. To summarize, inheritance is more than just methods. It includes data. However, for instance variables, we face a conflict when the child defines its own constructor. Method overriding allows a child class to provide a specific implementation for a method that is already provided by its parent class. Join me in Lecture 18.04, Overriding. See you there. Welcome back. While inheritance promotes code reuse, sometimes the general method inherited from the parent class isn't quite right for the child class. In such cases, the child class can provide its own specialized implementation of that method. This process is called method overriding. 1. Definition of overriding. Method overriding means creating a method in the child class with the exact same name and signature as a method in the parent class. When the method is called on the child object, the child's version is executed instead of the parent's inherited version. This allows us to specialize general behavior. 2. Overriding in action. We have a parent class, vehicle, with a general move method. The child class, car, defines its own move method with the exact same name. This new definition overrides the inherited one. 3. The child-first search rule. When we call c.move on the car object, Python follows a child-first search rule. It first checks the car class for a move method. Since it finds one there, it executes the specialized car.move and completely ignores the parent's version. This is the core mechanism of overriding. 4. Overriding the constructor. As we saw in the previous section, the constructor _init_ is also a method. If the child class defines its own constructor, it overrides the parent's constructor. This means that all the parent's instance variables are not automatically initialized, which can cause errors. We need a way to explicitly call the parent's constructor from the child's constructor to ensure proper initialization. To summarize, overriding allows specialization while keeping the inheritance structure. The super keyword is used to access methods of the immediate parent class, may be used to call the parent's constructor. Join me in Lecture 18.05, Using Super. See you there. Welcome back. In the previous section, we noted that when a child class defines its own constructor, it overrides the parent's constructor, which prevents the initialization of inherited instance variables. The solution to this problem is the built-in function super. 1. What is the super function? The super function provides a way to access methods and properties of the parent class, even if they have been overridden in the child class. Its most common use is within the child's constructor to call the parent's constructor and ensure all inherited instance variables are properly initialized. 2. Calling the parent constructor. Here, the person class initializes name and age. The employee class needs its own constructor because it takes an extra argument, salary, to ensure name and age are initialized correctly. The employee constructor first calls super.double_init_name, age. This delegates the initialization of common attributes to the parent, and then the child handles its own specific attributes like salary. 3. Testing the initialization. When we instantiate the employee object EMP, both the parents and the child's constructors are executed in sequence, thanks to super. We can now access all attributes, name and age initialized by the parent, and salary initialized by the child. The object is completely and correctly initialized. 4. Calling overridden methods. The super function can also be used to call any other overridden method, not just the constructor. If the dog class overrides the animal.speak method, but still wants to execute the parent's general logic before or after its own specialized code, it can call super.speak inside its own speak method. This allows for both specialization and reuse. To summarize, super is your bridge to the parent class, ensuring that you reuse and initialize inherited components correctly. This concludes our module on inheritance. Polymorphism, meaning many forms, allows objects of different classes to be treated as objects of a common type, often facilitated by duck typing. Join me in Lecture 19.01, Introduction. See you there.